On behalf of the Department of Chemical Engineering and IICAG Veltech Hightech Student Chapter, I welcome everyone to the seminar on spectroscopy and chromatography techniques. I also extend a warm welcome to our beloved alumni, Mr. J. Roshan Raj, Product Specialist, Spinco Biotech, Chennai. He has also excelled in high-performance liquid chromatography, gas chromatography, and Excel. He was also awarded with the Best Innovator of the Year in Chennai International Youth Fest in August 2017. Now I kindly request our beloved HOD, Dr. J.P. Veeramalini, to felicitate our chief guest. Welcome. I request our meritorious alumni, Mr. J. Roshan Raj, to take over the session. Welcome, sir.
So it's like really good to see you all in this session. So once again, thank you for the introduction. I just wanted to thank Dr. Veeramalini Madam, HOD, Department of Chemical Engineering, for welcoming me to deliver this guest lecture. And I once again thank all the department faculty members as well in this moment. And let us move further with the presentation which I have brought and the guest lecture of the topic spectroscopy and chromatography techniques. So I think most of us are like very much familiar with Tamil and right. So we can have this session like very much interactive. Okay, I just want all of you to interact with me and ask a lot of queries technically, so that the session will be like more reaching to your end. So let us make this session interactive. And always innovative ideas from your end is always welcomed, and you can also mail your ideas to me. I'll just share my email ID to you as well. And once we are getting more innovation from your end, I can also pull you in to my company to like for a 1 month of internship program also. So you can do your research work or your final year project works in our facility in Chennai. Right? So make sure that we make this session more interactive, right? Okay guys? So I'm like very nearly passed out alumni of college, so I was like doing my program from 2015 to 19, and later I have jumped into multiple organizations, and now I am with Spinco. Right? So let us start off as one of your friend have introduced about myself, that Roshan Raj. I am a product specialist. Okay, so particularly I take care of the technical aspects of two chromatography instruments on particular. One is called as liquid chromatograph, another one is called as gas chromatograph. Right? So these are all my two product of expertise. And moving further, I just wanted to introduce about my company. So Spinco Biotech. Okay. So we are in partnership with a Japanese-based company called as Shimadzu, right? And we have been established in Chennai in the year of 1981. So we have already crossed 41 years of excellence in serving the community of scientific research. So as you can see that Shimadzu. So what is Shimadzu? Basically, I just have a visual, an audio-video visual to tell you what Shimadzu does. And I hope we don't have audio, right? So not a problem, you will be having subtitles in the end of the video. You can like go through that, and in between let me like pause the video in between and I'll just explain you what is there on the video. Right, so this is what Shimadzu, and they are doing their contribution to scientific society for more than 100 years, right? So these are all the timeline with respect to their launch, the recent launch of the instruments in the field of chromatography and spectroscopy. And we don't not only deal with the analytical instruments, we also see this is the analytical instruments where you have water testing, food testing, and drug testing. So these are all the three main domains where the testing of the products happen. So to test those molecules, you need an instrument, right? So that instrument is nothing but the analytical instrument which we are about to speak. So that's the measuring instrument, and it has a diverse area of applications. Okay, it may be starting from pharma, food, petrochemicals, where we use gas chromatography, and it has a lot of applications in the field, and even In the field of say construction chemicals, we have a very good scope with respect to this instrument. So we not only do deal with the analytical instruments, and we also go with the heavy machinery parts and more towards the aircraft equipments, and we are supplying multiple critical parts for the aircraft equipments as well. And we have also given multiple instrument to ISRO as well. So you can see through this video that 63% of our business is from the analytical field, and rest the aircraft, what I have told you, and medical field and all these fields, we have the businesses being going on. And this is nothing but a figure of, this is basically a corporate presentation or corporate video, right? So there they have spoken about their revenue, how is their growth, and what scope they are having in the near future. So they are towards the sustainable development, and that's their goal. And most of the companies, most of the corporates now in the market has this as their midterm plan in terms of the sustainability with respect to the energy which they consume. And even Shimadzu has that. And this is the three area of business: human health, industrial development, and the scientific society. So research and development basically. So these are all the scopes where we are working in order to support the scientific field. So that's all about Shimadzu, guys. And I hope you are very much clear what we do and what kind of instruments, what category of instruments which we deal with. Fine. So am I sounding like monotonous? So like this is the corporate presentation, like getting end, it will be like that. And once we go into the instrumentation part, we will be having more towards the technical discussion. So we'll discuss a lot of things. And I just wanted to know that we all students over here is from Department of Chemical Engineering, right? Biotech as well, right? Great. Okay. So we'll cover both the worlds, okay? Actually, from chemical engineering and also the biotech related applications, right? So we are mostly second, third year, right? Not final years. Okay. So might be third years. So how many of you like gone through the paper called instrumental method of analysis? Instrumental method of analysis. Second years, right? In second years you get it in your life. Right, so we are here to deal about that one thing, to be more particular. Right? Yeah. So as we seen about Shimadzu, now let me tell about what Spinco does. As I told you, it is a 40 years plus old organization which was established in the year of 1981. So we have around 33 offices on pan-India level, and our head office is located in Chennai, Perungudi. Okay, there we have a huge laboratory where we have multiple instrumentation techniques, and to be more precise, we have all range of instrument. You name it, we have it, like the kind of laboratory setup we have. So what we do over there is more towards the recent trends and recent application in the terms of scientific field or this analytical field. So we do our projects, we take up projects from industries like Pfizer or any industry you name it, we take projects up from them and we solve their problems and we give the solutions to them. So that's what the facility we have it in Chennai. That's why we claim it as the head office of Spinco Biotech. And as I told you, we have 33 offices on pan-India level. And we have three verticals. So one is called as I've told you before about Shimadzu introduction, we were like focusing on chromatography, bioresearch and process technology. So we have instruments to complete all these three verticals. So even Spinco Biotech does the same. So they have three verticals, like one is with respect to chromatography and mass spec, and the next one is bioresearch, more towards the biotechnology and where we do multiple research, and we have multiple openings as well in that terms. And next one is process technology, where we have a chemical engineers team placed here, and we deal with multiple process technology instrumentations as well. Right? So that's the three verticals of. I hope the slide is visible to you all, right? Very much. I think it's right now. You can slightly increase the brightness. If it's not possible, then not a problem. Right. So we have more than 750 plus employees working on India. So that's all about Spinco Biotech and Shimadzu, guys. And let us directly dive into the topic of guest lecture, chromatography. So to explain you about chromatography, it is chromatography itself is a Greek term where we claim chroma means color, graphy means to write, graphical representation. Right. So that's what chromatography is meant for, and we have the chromatography has been discovered in the year of 1900s, where we have a Russian botanist named Michael Quest. Okay. So let me tell you a quickie story. Okay. So what he did was he had alcohol and a ether. Okay. Then the solvent mixture he was having, and what he did was he tried to use those solvent and extract the take an extract based out of plant. Okay, so he obtained a plant-based extract which was being done more years before that as well. So what he did is he collected that plant-based extract which has two solvent in it, ether and alcohol. Okay, so what he did was he percolated. What does mean by that? He just poured it in a porous material or an adsorbent material. Okay, nothing but calcium carbonate. What happened was he could find basically till the time of 1900s there was it was understood that there were only two pigments in plant. One is, any biotechnologist? What are the two main pigments in plants? Chlorophyll. Next. Exactly. Xanthophyll. So till that time, it was understood that we had these two based pigments, and I want you guys to open up, right? Okay, randomly you can pick up yourself and ask queries, and that makes a bonding between you and me, so that I can support you more towards any of your scientific research or your project or towards that. Okay, so I just want a particular person to give the reply promptly, right? So we'll make that session as such as interactive. Done. So it was chlorophyll and xanthophyll. What he observed while he percolated it into a calcium carbonate based porous material adsorbent, what happened is he could find there were two bands for chlorophyll and 8 other pigments. So in total he had around 10 pigments being present in that plant extract. So till that people believed that there were only 2. But he got 10 bands. So what are those? It are all related components. I am not naming or listing it out. So this is what the activity he done. So what he has done, what is the activity which he has performed? He had a mixture. Out of this process, he has separated the mixture. So the process which happened is called as separation. Correct? A pigment was in a mixture. He separated using the adsorbent material. So this science is called as chromatography basically. Chroma, color, graphy, right? That's all to one extent. But chromatography actually is nothing but a science of separation. So anybody, could you please list down what are all the separation techniques which we have learned? Different types of separation techniques. Great. Distillation next. Sorry? Okay. So we have multiple techniques for this, okay? We had multiple techniques for this. Out of one technique is nothing but chromatography. Simple. So to perform this chromatographic technique, we require something. Correct. So as Michael Twent has had a solvent, and he also had an adsorbent, right? So this solvent is nothing but going to move through that adsorbent. Correct. So let us call it as mobile phase since it is moving. Whereas the adsorbent material which he had was calcium carbonate, right? So that was a stationary one. It was not moving, so there is no process happening in that. We can't say that there is no process happening, but it is stationary in one place, whereas the solvent was a moving one. So let us claim this as the moving phase is called as mobile phase, and the stationary one is called as stationary phase. So these two are the requirements to carry out the chromatographic technique or the science of chromatography basically. So more towards this, after 1900 there was multiple advancement and there were different techniques being introduced in the market, and it has been commercialized as well. That's the history of chromatography. Is there any doubt still now? So what is mobile phase, what is stationary phase? I think you should have understood, right? So let me move further. So I have mentioned mobile phase and stationary phase. He is my pupil. And I have listed out few commonly used chromatographic technique, out of which first two we will be discussing today, and rest all I will just give you a glimpse on what we do. So if you find the first one called as high performance liquid chromatograph, okay, there they have chromatograph is a common term, high performance liquid. So there, by stating it as a liquid, you can understand that the mobile phase is in liquid phase. Right? So why do we state it high performance? I'll tell you in the later part. Let me go to the next point. That is gas chromatography. Right? So obviously, what is the mobile phase there?
Yes.
Exactly. So liquid chromatograph, gas chromatograph. Simple as such. The next one is called as gel permeation chromatography. So gel permeation. So there is a gel inside which there is some permeation being happening. So what is understood from that end? No, not two phases. Obviously there are two phases. One is stationary phase, another one is mobile phase. But there is something permeating through a gel. So what is the gel? It's nothing but a stationary phase. So in the previous technique, they were specifying, they are categorized that technique based upon the mobile phase, whereas in the gel permeation chromatography, they are categorizing it based on the stationary phase. Exactly. So they are using a kind of gel in order to carry out the chromatography technique. Right? Next one is ion exchange chromatography. What is like understood? There is a material and you are like dumping down the compound of interest, that is an analyte. So you are getting that sample loaded up in the system of chromatography. So there is an ion exchange happening. So if it is based upon the ions, then it is called as ion exchange chromatography. Simple. Then we have supercritical fluid chromatography. What is supercritical fluid? What is this state? Any idea? Right. So let me give you a what to say, an assignment or kind of thing. I'll share my mail ID. Somebody do a write-up, go and refer Wikipedia, Google, and you have a lot of articles about supercritical fluid chromatography. So you just simply make a write-up. Just explain what is it and where is the field of application and share it to my mail ID. Okay? I'm sure I can get you a job out of it. Clear? I'm very much sure, but it should be like the write-up should be very appropriate, okay? Not something like a random thing or copy pasting from Wikipedia. You just do that and also give some innovative idea on that, what project that thing can be done. Why? Because this supercritical fluid chromatography is on its peak now. Okay? So that's all I could explain. Supercritical temperature, anybody, do you have any idea on supercritical temperature? What is it? So I just give a basic idea. So can you liquefy carbon dioxide? Yes, it can be liquefied. So how to liquefy it? So that temperature, that point of temperature and pressure is nothing but the supercritical temperature, supercritical pressure. So post which this it won't be in gaseous phase, neither a liquid phase. It is in between two kind of thing. So that point is called a supercritical fluid. That is being used for carrying out this chromatographic technique, and hence that has become a technology. Clear? And the next part is TLC, a commonly used basic, in any basic lab you can find a TLC being used. It is nothing but a sheet of paper where you will be placing spots and you will put it down in a beaker having the mobile phase. So out of capillary effect, what happens? The mobile phase starts flowing through the thin TLC sheet. Right? So as the mobile phase is flowing, the separation happens, and hence that's the technique. A basic technique where there is no much of instrumentation being used. Whereas the rest of the techniques which I have discussed before has a lot of instrumentation technology being implemented there. Whereas in TLC there is nothing as such. You just simply need to have a mobile phase and the TLC sheet and the beaker. That's more than sufficient. You can perform the analysis. Affinity chromatography and dye-ligand chromatography. These are all also an upcoming chromatography technique which has not been established to its maximum. Right. So, as we have discussed earlier, we will be particularly focusing upon 2 points. One is HPLC, another one is GC. Okay, high performance liquid chromatography, and the next one is gas chromatography. So I have a couple of HPLC pictures as well, before which I just wanted to explain you what is HPLC first. Then we'll go through the picture and all these parameters, everything we'll discuss today. So Jack, he was the father of HPLC, and first HPLC was launched in the late 1960s only. Okay, a proper instrument for the market, a commercial instrument where anyone could procure that and do their research activity. So it was launched by a brand called as Waters. Still they are there, and that is a US based company. So they have launched this first HPLC in the market. Right. So I have specified the model name, that's not required anyhow. Now, high performance liquid chromatography. So I have told you the stationary phase is nothing but, the mobile phase is here is nothing but, liquid. Right. So what about the stationary phase? Okay. So stationary phase is nothing but a packed column, let us consider. I'll just show you an example of packed column. You can see this one, something like would look like a pencil, okay? So this is nothing but a column, a stainless steel holding inside which there is something called as packing material. Okay? Basically these are silica. Okay? The stationary phase is nothing but silica. Right? So silica is doped with certain carbon atoms, or carbon molecules to be more precise. So we will call this silica based packing material as C18 group, C8 group as such. Okay? And we have the mobile phase is nothing but it can be any solvent. It may be like a water or any buffers, potassium buffer, ammonium based buffer, or anything else as such. So I am coming back to the previous slide. So as I have told you, we have two phases here. Stationary phase is nothing but a silica based packing material, and the mobile phase, it may be any solvent. I will explain you what are all the solvents which can be used. There are also restrictions for that as well. Before which, what is the science behind the separation? What happens? Previously I have told you there is ion chromatography, affinity chromatography, ligand chromatography. These are all, the working or the base science is different when it is compared with HPLC. So here the separation is happening because of polarity. Can anybody define what is polarity? Anybody? You can go below. Anyway, phones are allowed. Not allowed. Right. Okay. So what is polar solvent, non-polar solvent? Polar for example, what is polar solvent? Exactly. So you got the point. So in the separation, right? So here the separation is happening because of polarity. So there is two categories. One is highly polar, another one is highly non-polar. These are the two categories. Okay. So just like magnets, if north pole magnet or north pole magnet attract aguma, repel na agum. Adhe mari north south attract agum. In similar way, the polarity of your mobile phase, if it is polar, polar na water wish pannrom mobile phase la. So that is polar. Appo column enna varuknom? Simple. So unga mobile phase polar irukna, column vandu non polar iruknom. Column non polar, column polar irukna, mobile phase non polar iruknom. So ஒரு solvent வந்து polar or non polar எப்படி கண்டுபிடிப்போம்? How do we find whether a solvent is polar or non polar? Any idea? So okay, idea is simply go and Google. So you will find something called as polarity index. Okay, I'm not diving into the basic chemistry class. Okay, so anyway, that's all the time has gone. Anyway, you can go and refer a polarity reference chart from Google where it will describe about the solvent's polarity. I have that in the slide as well. So this is nothing but the polarity index chart where we have stated that water is highly polar in nature. So what is the polarity index of water? It's 10.2. Okay, what is highly non-polar in nature? That is nothing but hexane. Right? So whether water and hexanes are visible. Water hexane visible ah? It's invisible. Okay, so what happens is this isopropanol stands in between of the polarity chart. So in the isopropanol க்கு கீழ இருக்கிற எந்த solvent வேணாலும் நீங்க யூஸ் பண்ணலாம் with respect to non polar column. ஓகேங்களா, ஐசோப்ரோபனாலுக்கு மேல இருக்கிற solventலாம் நீங்க யூஸ் பண்ணனும்னா polar column வச்சிருக்கணும். Clear? So like something pH க்கு எப்படி சொல்லுவோம், 7 is the midpoint, anything below 7 is called as acidic, anything above 7 is called as base, strong base, strong acidic, அந்த மாதிரி தான். So similarly in the terms of polarity index chart, that isopropanol that is having the polarity of 3.92, anything below isopropanol is called as non-polar, anything above isopropanol is called as polar. Simple. Clear? So this is how we select the solvent. And the next part is, so solvent எப்படி select பண்ணனும் சொல்லியாச்சு. What about the column? Column slide second. So this is the இங்கே column கான slide இருக்கு. So all these chemistry belongs to the non-polar chemistry. இதுக்கு ஒரு reference chart தான். Anyway, I'll share these charts or presentation to you. So anything in this category can be used with water-based solvents as such. So எல்லாத்துக்குமே you will be having a reference chart in order to work or in order to do the research work. Yes? Any doubts? Till now, do you have any doubts?
And those who are not interested can go out. Not an issue. He was openly giving a chance to us to work in the co-company. You people will not know listening what he says. Do you know what he has given the statement? He has given one assignment. If you submit the assignment, he has given the opportunity for working in the co-company. You people not at all noted down. And you never asked about this meeting. Those who are not interested, please go out.
Right. So anyway, we move. So that's all about எப்படி ஒரு solvent, எப்படி ஒரு எப்படி ஒரு mobile face select பண்றாங்க, எப்படி ஒரு stationary face select பண்றாங்க. You have reference data for that. So here the basic science is nothing but polarity. The separation happens because of polarity. So that's about it. So what is the difference between a chemist and a chemical engineer? The first moment when you step down to an industry, this is the hurdle you will be facing. Any chemical engineer they will face it, since I am a chemical engineer again. So what is the difference between a chemist and a chemical engineer? Okay. Okay, you are more into like pharma, correct? In respect to the pharma domain, that's what happened in the market. So basically, chemists understand what's the reaction, what's happening, and everything. Okay, what a chemical engineer does is scale up. Okay, so we have, what is the population of our world? More than 7. Exactly. So we need every product to reach every individuals. So that's the main motto. So in that terms, a chemist can do a process or carry out a reaction in grams, not even grams, milligrams, nanograms. Whereas a chemical engineer can process it in tons. So he knows the technology, how to upscale it. Okay, that's the main difference. But it is not that a chemical engineer should not understand chemistry. He should. Then only he can upscale it. But a chemist need not understand it. Why? Because that's not his problem at all. Scale up. They don't bother about it. They will particularly more focused toward their reaction only. So scale up பண்ணும்போது what is the problem they will face? அதெல்லாம் யோசிக்கவே மாட்டாங்க. So whereas a chemical engineer should know the chemistry as well and he should scale up. So with respect to HPLC also, that's neat to know. Okay, so இதுல வந்து range of operations இருக்கு. Okay வா? So there are further 3 more categories, starting from small load of analysis to a preparative mode of analysis. Okay, so let me explain you what is UHPLC. Many would have known that UHPLC, analytical HPLC. in the rent category, is something different, and many chemists use it. Okay, whereas preparative is nothing but a chemical engineer can use it. They know the technology. So there is அதில் ஒரு பழமொழி இருக்கு. ஸோ எப்படி சொல்லுவாங்கன்னா, ஒரு பானை சோறுக்கு ஒரு சோறு பதம் அப்படின்னு சொல்லுவாங்க இல்லையா. ஸோ யூ ஹேவ் அ லாட் ஆஃப் product or a lot of molecules with you, out of which you will take some molecule and test it whether it is good or not. Correcta? So this is the activity. So in the மாதிரி ஒரு activity பண்றதுக்கு you are not going to consume the entire lot of the molecules which you have. Instead you are going to take very small amount, a trace amount, and you are going to work on it. So that, and even biotechnologists also is not going to go in the terms of 1 kg or 2 kg as such. No, that's not the case. They are also going to work on a trace level analysis, we call it. So to carry out trace level analysis, we have two range of instruments called as ultra high performance liquid chromatography, HPLC. That is normal HPLC, high performance liquid chromatography. So what is ultra high performance அப்படினா? It's nothing but ஒரு HPLC இல்ல ஒரு analysis or ஒரு quantification or whatsoever பண்ணனும்னா, if it is taking 40 minutes, using a UHPLC is going to take only 4 minutes. So for industries, time is money. Okay, but our HPLC, if it is costing around 25 lakhs, UHPLC will cost 60 lakhs. For them, that the price difference is not a matter at all. They will just like that throw it and get the instrument. Okay, but the time is money. They can't wait for 40 minutes. Instead, they can go for that 4 minutes and they can complete their process and send their product out or export it. So that's what basically UHPLC saves time, whereas HPLC takes time. So the next category, I have pictures for both UHPLC and HPLC. I'll show you. And the next category is nothing but preparative HPLC. This is where we are. So to be more focused on. So in the UHPLC or HPLC process now we are going to do in preparative HPLC. But this is nothing but a large scale production. In the UHPLC, HPLC, you can't commercially you can earn something, but you can't sell something out from the instrument. புரியுதா? கமர்ஷியலா அதை யாருக்காச்சும் ரெண்ட்டுக்கு இல்லைனா யாராச்சும் ஒரு ரிசர்ச்சர் வந்து அதை யூஸ் பண்ணிக்கிறதுக்கு they can take earning. That is different perspective. But அந்த இன்ஸ்ட்ருமெண்ட் யூஸ் பண்ணிட்டு வர அவுட்புட்டை they can either publish or they can issue a certificate that this is pure, this is impure அந்த மாதிரி they can give a certificate. Why? Because they are checking the quality. Whereas in the preparative HPLC use பண்ணிட்டு they can gain commercial value, not in lakhs, not in 10 lakhs above, not in millions, it is in crores. So அந்த அளவுக்கு ஒரு commercial value they can take out from the instrument. Since they are upscaling the process, they are gaining out a product from the instrument itself and sell it to the market. Okay, so that is what the preparative HPLC is all about. Analytical la pandra adhe chemistry, that's the same polarity, everything is same. For example, analytical la say for example 5 micron உள்ள ஒரு particle size, நான் சொல்லியிருந்தேன் சிலிக்கா particles na, this your stationary phase. So 5 micron இருக்கிற ஒரு சிலிக்கா particle யூஸ் பண்றோம்னா preparative 30 microns 50 microns உள்ள particle size யூஸ் பண்றோம். Simple as such. So you are scaling up the process, out of which you need to take the maximum yield. So I think all should know to take the maximum yield. That's the main motive of every commercial aspect. So அது எப்படி maximum எடுக்கிறது to optimize the analytical procedure. Optimize பண்ணிட்டா maximum yield இருந்தா maximum revenue. That's simple as such. So in the upscale process we are chemical engineers has a lot of scope. Whereas analytical aspects of front level பார்த்தோம்னா newborn screening. Biotechnologists here, anybody have you heard about newborn screening, the recent trend in the market? யாருக்காச்சும் தெரியுமா? Any idea? No. Okay, so if you don't know, then you are a little bit outdated. I hope you should know about it. You have a lot of scope on that field. And anybody heard about LifeCell company? LifeCell, கேள்விப்பட்டிருக்கீங்களா? No man, really? LifeCell கேள்விப்பட்டிருக்கீங்களா? I think, huh? Yes, stem cells, exactly. I think a couple of seniors is also working there. LifeCell work பண்றாங்க from our institute. Okay, so in LifeCell and all they use this technique only. So they are doing stem cells and they are storing it, and for that quantification, all these technologies, they use this technique only. Chromatography is the key point. So this newborn screening is the upcoming future with respect to a particular domain. There is like multiple domains, out of which newborn screening is also in its peak. Okay, so make a note of it. Right. So preparative, I hope you have understood what is UHPLC, HPLC and preparative. I think you are very much clear. Any doubts till now? No. Okay. Just for a fact information, how many of you know NACO Pharma? NACO Pharma, yeah. So out of which they are basically a drug manufacturer, and out of this drugs manufacturing, you have some terms called as impurities. Okay, process impurities, in-process impurities அப்படினா சொல்லுவாங்க. So இந்த மாதிரி preparative யூஸ் பண்ணி என்ன பண்ணுவாங்கன்னா இந்த impurities தான் they would collect it as a pure standards. Okay, so out of which we did a project recently, like 2 months before. 1 week we have took a revenue of 48 crores using 3 preparative HPLC. So 1 week they can do a lot of collection of the sample. So andalukku it has upscaling capabilities. So it can develop the impurities and they can separate it out from it. So we have sold it to NACO Pharma. Naanga pannirukka the project and we have handled the project to them. So in the Mari we work on lot of recent trends, okay, and we solve problems of the industry. So that's what we do there. So that's the preparative scope, analytical and UHPLC scope. Right. So, okay. So can I perform random molecule whether I can put it down in a HPLC system and can I carry out the analysis? First option is your sample should be soluble. Okay, the sample should be soluble in some solvent, any solvent. Okay, since you have a wide range of polarity solvents in the polarity chart, any solvent soluble and it can be analyzed using a HPLC. Okay, simple as such. So solubility is the key point. If it is insoluble, forget HPLC. It can't be handled. It can't be used to handle that particular sample. Right. So civil எடுத்துப்போம். So civil engineering அந்த மாதிரி ஒரு இடத்துல இது அப்ளிகேஷன் இருக்குமா? Any idea? Do we have any இந்த மாதிரி ஒரு chemistry oriented-ஆன ஒரு thing civil engineering-ல application இருக்குமா? Recently ஒரு like இந்த மாதிரி தான் full session will make it interactive. What I have faced in the industry, நான் என்ன மாதிரி project எடுத்திருக்கேன், that's what I am going to discuss while speaking about the technical aspect. The whole session guest lecture is going to be as such. Okay, simple. So what are the projects I did and the So how many of you know Saint-Gobain company? So Saint-Gobain is a famous construction materials manufacturing. They don't only manufacture glass, they have multiple divisions there. Okay, so for them we have did a project with respect to HPLC material. So how many of you know this is the gypsum board? Correct, fall sitting they use gypsum board. இதை எடுத்துட்டு போயிட்டு HPLC-ல போட்டு அனாலிசிஸ் பண்ணுவோம். Okay, so they export. Saint-Gobain does this multi-millionaire or multi-export king. Okay, they do lot of export with respect to this gypsum board. Okay, recent or environmental crisis what happened? Gypsum board they are mixing biocide. What is biocide? Biocide pa. Anybody? So, it's not a pesticide. Biocides means if the gypsum board மழை பெய்யும் போது இந்த gypsum boardல ஒரு fungal issue, fungal இது form ஆகும். கரெக்ட்டா? So அது form ஆகாம இருக்கிறதுக்கு இந்த gypsum board manufacturing they mix biocide in it. ஓகேங்களா? So all of a sudden Saint-Gobain உடைய exports they stopped it. ஓகேங்களா? Why? Because US FDA. Anybody knows? Yes sir. So what they did was to quantify what is the release of biocide over a period of 2 years, 5 years, 10 years, or throughout the lifetime of the gypsum board. What is the release அப்படின்னு கேட்டால் ஒரு மெட்டீரியல் இதில் நான் மிக்ஸ் பண்ணி ஐ எம் மேனுஃபேக்சர்ட், இட் இஸ் ஃபேஸிங் தி என்விரான்மெண்டல் வியர் அண்ட் டியர். ஓகேங்களா? அப்படின்னு இருக்கும்போது ஒரு மழை பெய்யும் போது இந்த ஜிப்சம் போர்ட்லேருந்து என்ன மாதிரி ஒரு பயோசைட் ரிலீஸ் ஆகுது? இஸ் இட் கண்டாமினேட்டிங் த சாயில்? ஸோ இட் இஸ் கோயிங் இன் டு த ஃபுட். இஸ் இட் லைக் வேப்பரைசஸ், ஹை டெம்பரேச்சரும் வித் ஸ்டாண்ட் பண்ணுது. இட் இஸ் லைக் கண்டாமினேட்டிங் த ஏர். ஸோ வாட் இஸ் தி பொல்யூண்ட் அவுட் ஆஃப் இட்? So in the Mari, they have asked to quantify Saint Gobain in order to sell their product in US. So US will not fall ceiling they can't. Correct? So it is a big problem for them. Then they found out a chromatography technique only as a solution. They have used gas chromatography and they have also used liquid chromatography for only one molecule, whereas rest all they have gone with the gas chromatography technique. So they have solved the issue. They have stated they had this accelerated study out of which they have studied in and out of that board, and they have just declared the results to the US FDA. They came audited, they threw the audit, passed, and they have started to export it. So in the Mari there is countless applications, guys. So it is not only chemistry, chemical, polarity, nothing. So in this world everything is made out of carbons, correct? So in any molecule there is carbon in there. So any carbon based molecule can also be taken down to the application. The particular point is how to do that. What is the method to do that? At the number then you can exit. Yeah. Any doubts till now? Just any doubts? That's application oriented. Any thoughts or anything is striking? Maybe you should be doing some mini projects kind of thing by this time, right? So on the Mali, that's a thought you can get to me. Then, so what is qualitative? What is quantitative? Already we have basic, but basic indirect. What is qualitative? What is quantitative? Anyone? Sharpa, crisp or answer? And the term itself explains this. Qualitative அப்படினா ஒரு மெட்டீரியல்ல இது இருக்கா இல்லையா அவ்வளவுதான். If it is there, it is there. That's it. ஓகேங்களா? Whereas quantitative அப்படின்னு கேட்டோம்னா, for example, ஒரு water bottle இருக்கு. You have to get from somewhere. Okay? Whether do you have chromium in it or not? அவ்வளவுதான். So that is qualitative. இருக்கா இல்லையா அவ்வளவுதான். That's what it can say. Whereas quantitative analysis na, what is ppm? What is ppb? எவ்வளவு ppb இருக்கு? 10 ppb ஆ 20 ppb ஆ? What is ppb? Correct. So how much ppb you have that in that? So what is the limit of intake which a human can take to not to develop any carcinogenic activity in their body? So another limits they would have WHO would have announced that. So based out of that, that quantitative study is way more important. Now nowhere they do qualitative. Quantitative analysis is only the key, and for doing this quantitative analytical technique, this is the way to go for. Clear? Any doubts till now? Fine. So as I have told you, this is the preparative HPLC. So I will start from preparative and the HPLC carton and UHPLC carton, right? So this is the preparative HPLC. You can see they have large volumes of water, and either very bottles so they will use to handle. And this is the preparative instrument, out of which they do the separation. So this is mobile phase on large volume. Why? Because we are upscaling the process. Correct? In analytical scale, we will be having 1 ml, 2 ml, and whereas in preparative scale, it is going up with liters, 10 liters, 25 liters, 50 liters. That's how the scale increases. So as per the scale, they can modify the solvent. So solvent modify panna poduma. Packing material, exactly. So you should modify your packing material also. Believe me or not, a column size in the size level, not even more size more than my finger, with the respective UHPLC column. Analytical column na idu irukum. Okay, preparative column na ee height irukum. Enna vida height irukum. So that's what the scale is, okay? So UHPLC na இவ்வளவு உள்ளதா இருக்கும். Analytical கொஞ்சம் பெருசா இருக்கும். Preparative என்ன விட ஹைட்டாவே இருக்கும். So அந்த மாதிரி காலம்ஸ் தான் இருக்கும். உங்களுக்கு இங்க ஒரு காலம் இருக்கு பாத்தீங்களா? This is nothing but a packed column. Okay? What happens is ஒரு solvent place பண்ணிடுவோம். The solvent packed column உள்ள கவுண்ட் பண்ணுவோம். Clear?